Ramanujan for G is now available on the Google Play Store. Try it out for free.
Good morning, class. Today, in monotonicity, first we will look at few examples. Okay, so topic is so question is given like function fx is equals to x cube minus 27x x cube minus 27x plus 5 is monotonic monotonic increasing when x is less than minus 3, mod x is greater than 3, x is less than equals to minus 3, and fourth is mod x is greater than 3. Okay. So solving it means fx will be monotonic increasing if f dash x is greater than 0. So we can say 3x square minus 27 is greater than 0. So it means x square is greater than 9. So mod x is greater than 3. Right? Mod x is greater than 3. So it means option number 2. Okay, so copy this. Next problem. Function fx is equals to cos x minus 2 lambda x is monotonic decreasing decreasing when uh, options are lambda greater than half, lambda less than half, lambda less than 2, and lambda is greater than 2. So, so we can say fx is monotonic decreasing when f dash x is less than 0 for all x. So sine of x minus 2 lambda is less than 0. So we can say 2 lambda is greater than minus of sine x. So it becomes 2 lambda greater than 1. So lambda is greater than half. So it means the correct option is first, right? Okay, next, the function. The function x is equals to x minus of log 1 plus x, where x is greater than minus of 1 is increasing. Okay, so to find the increasing interval. Okay, so fx is equals to x minus log 1 plus x is greater than minus 1. So f dash x is equals to 1 minus of 1 upon 1 plus x. So it becomes x upon 1 plus x. So x of 1 plus x divided by 1 plus x whole square. So if we write sign convention for x 1 plus x divided by 1 plus x whole square. So it means we can see, we can take it from minus infinite to this side plus of infinity. Somewhere 0 is here and minus 1 is here. So if you look at this side, it will be positive, this will be negative, and this will be positive, right? So from this, we can say if f dash x is greater than 0, if x is greater than 0, so but x is greater than minus 1, so f dash x is greater than 0 if x is greater than 0. So fx is increasing in interval 0 to infinite, right? 0 to infinite. This is our answer. Next thing is function fx is given, which is mod of x minus 1 divided by x square. Okay, and options are if increases in minus infinite to 0 union 1 to 2. Second again increases in 0 to 1 union to infinity. Third option decreases in 0 to 1 union 2 to infinity. And the last option is decreases in minus infinity to infinity union 1 to 2, right? So we can solve. So fx is equals to x minus 1 divided by x square. So which means x minus 1 divided by x square. So x is greater than 1. Similarly, 1 minus x divided by x square. X is less than 1. X is not equals to 0. Right? So we can see f dash x is x minus 2 divided by x cubed, which is x less than 1 and x is not equals to 0. And this does not exist at x equals to 1. And 2x 2 minus of x divided by x cubed, which is x is greater than 1. So clearly we can say f dash x is greater than 0 and x is less than 0 or 1 less than x2, right? So f dash x is less than 0 for x 0 to 1, or we can say x is greater than 2. So fx is increasing for minus infinity to 0 union 1 to 2 and decreasing for 0 to 1 union 2 to infinite. So in this we can see option 1 and 3 are the correct options. So you can copy this. Next problem. Let f dash x is less than 0 and z dash x is greater than 0 for all real x. Then we can say f of z x plus 1 is greater than z of z of x plus 5. Option 2, f of z is greater than f of z, f of x plus of 2. Third option is z of f of x is less than z of f x plus of 2. And last option is z of f x is greater than z of x minus of 2. Right? So now we will solve this problem. So first we know f dash x is less than 0 and g dash x is greater than 0. So we know gx is increasing and f dash x is decreasing, right? So we can say x plus 1 less than x plus of 5, which is z of x plus 1 less than z of x plus of 5. So f of z x plus 1 is less than f of z of x plus of 5. So again, x less than x plus 1. So it means z is x plus 1. So it becomes f of gx is greater than f of z x plus 1. So if x is greater than x plus 2, then it again become fx is greater than fx plus 2. Then g of fx, which is greater than g of f of x plus 1. So similarly, x is greater than x minus 2, then we can write fx is less than f of x minus of 2. So that means z is fx less than z of fx minus of 2. So a correct option will be this first. Okay, so you can copy. Okay, so next is properties of monotonic function. This is the last part. Later we will solve examples for this. We'll take 10 to 15 examples. Okay. So the first property is if fx is strictly increasing, if fx is strictly increasing function on an interval AB, then f inverse exists and it is also a strictly increasing function, right? So this is the first one. The second one is if fx is strictly increasing function on an interval a to b such that it's continuous, then f inverse is continuous. F of A and F of B, right? So this was our second point. Third is if fx is continuous on A to B such that f dash c is greater than equals to 0, and means f dash c is greater than 0. So for each c belongs to A to B, then fx is monotonically increasing on A to B. Next property is fourth one, like if fx is continuous, if fx is continuous on A to B such that f dash c is less than f dash c is less than 0. So like it's for each of c belongs to A to B, and then fx is monotonically decreasing function of A B. Okay. Fifth, if fx and gx are monotonically increasing, it may be strictly or strictly decreasing or decreasing function on A to B, then of x is monotonically increasing function. Last is if one of two functions fx and gx is strictly increasing and strictly decreasing, then of x is strictly decreasing on A to B, right? So with this, we are at the properties. Now we will take one question. Okay. Then questions of previous years, like 10 to 15 questions, we will do in the next class. So for today's, we will get one example only. So let fx is equals to cot inverse z of x, where gx is an increasing function for 0 less than x less than pi. Then fx is, like options are given, increasing 0 to pi, decreasing 0 to pi, increasing in 0 to pi by 2, and decreasing from pi by 2 to pi, and last option is none of this. So let's solve. So we have fx is equals to cot inverse z of x, right? So f dash x will be minus by 1 plus z of x whole square, this into g dash x, this is into g dash x. So for this is less than 0, for 0 less than x pi. So gx is increasing for g dash greater than 0. So it means fx is decreasing 0 to pi. So option 2 is the correct answer, right? So with this, we have completed the monotonicity. Next, in next lecture, we will solve the examples. Okay, so thank you guys.